This tutorial will teach you how to create a basic CellML model using OpenCell. We're going to model the following basic reversible reaction. Using mass action kinetics, we can model this reaction using the following four equations. Now let's build this model in CellML using OpenCell. The OpenCell interface is divided into four main areas. The model tree displays all currently open models. The tree view pane is where most of the editing is done. Below this, the integration and display pane displays information in a context-sensitive way and controls integration, and the graph pane displays results of simulations. All of these panes can be moved around or snapped shut if you don't need them for what you're currently doing. Let's start and create a new model by clicking on the New Model button. Make sure your model is in CellML 1.1. We'll call our new model Tutorial Model. Now we'll save the model. Again, give it the file name Tutorial Model. As you can see, the model has appeared in the model tree. Now we'll change to the Show Complete Model Structure Tree view where most editing is done. First we'll create our two components, an environment component to contain global variables, in this case time, and the flux component to contain all the other variables for the model. Now we can start creating variables. We can put the time variable in the environment component, and we can create all the other variables we need for the model in the flux component. Here we have the three concentrations of the reaction species, A, B and C, the rate constants, Kf and Kb, the flux, J, and we have time again. This is because later on we have to connect the global environment variable time with the time variable in the flux component. Now we're going to add initial values for the variables A, B and C and the two rate constants Kf and Kb. All variables in a CellML model have to be associated with units. OpenCell comes with a range of built-in SI units which we can associate with variables. We'll associate the seconds unit with the time variables. All of the other variables have units that we need to define. To do this, we build them up using the built-in SI units combined with prefixes and exponents. Let's define the units of micromolar for the concentration of the three reaction species. We do this by selecting moles from the built-in units. Then we add the prefix micro from the drop-down box. Alternatively, you can just enter the number in the text box. Next we add another unit and make this litres. To make this per litre, we'll change the exponent to -1. If you now go and select the micromolar unit from the tree, you can see its details displayed in the display pane. Now we'll define the other units we need for the model. We need a unit of per second for the Kb variable. To define this unit, simply select the units of second and then change the exponent to -1. We'll also define a micromolar per second unit for the flux. This is defined by simply selecting the unit we already defined for micromolar, and then the other unit we defined for per second. The last unit we need is for the other rate constant. This is per micromolar per second. To define this, we simply choose the micromolar unit again, and give it an exponent of -1 to make it per micromolar. Then we combine this with per second to make per micromolar per second. Now let's go and apply these newly defined units to our variables. The three concentrations, the two rate constants, and the flux. Now I just have to flip between two different views to get rid of the glitch that stops me from selecting the unit. If you find any glitches like this, please do report them on our tracker. Now we're going to create the equations for the model. We do this by creating a new maths node and then adding 4 equations to it. To enter equations, just type them in this equation box. The first equation for the flux is J equals Kf times A times B minus Kb times C. The equations for the reaction species are differential equations. For A, it's dA over d time equals negative J. As you enter the equation, you can see it appear in the display pane below, and once completed, it will be rendered as a formatted maths equation. Now we enter the equations for the other reaction species, B and C. The last thing to do on this model is to connect the two variables, time in the environment component with time in the flux component. To do this, we create a new connection. Select the connection and select the two components you want to connect, environment and flux, in this case the only two components in the model. When you click on the connection, it will show you the two components that you've connected in the display area. Now we need to create a variable mapping within that connection. Within this variable mapping, we choose the variables of each component that we want to connect. Time in environment with time in flux. Now if you click on the connection, the details will show the variables as well as the components which are connected. The red X means that we haven't selected a direction for this connection yet. To do this, we need to set the public interface for the two time variables. We need to set time's public interface as being out from the environment component and in the flux component. Now if you click on the connection, you can see an arrow which indicates the direction of this connection. This model should now be complete and ready to run. We'll save the model first, and then we'll use OpenCell's validation service. Right-click on the model in the tree and select Validate. As there are no errors in this model, you get a nice friendly message. If there were errors, they would appear in this area, and they could be clicked on to show where the error is in the model. We can now integrate the model, first by clicking on the Show Integration Pane button, and then clicking on the Integrate button in the integration pane. Once it's finished, you'll get an integration complete message, and you can export the results as a CSV file. To graph results, open the context menu below the graph and add a new trace. Select time as the X variable and A as the Y variable. Here you can see a graph of concentration of A over time, in this case 10 seconds. Now add 3 more traces to the graph. Every time you add a trace, the X variable is consistent with what you've already selected for your first trace. Now change the Y variables to B, C and J. You can change the color of your traces by clicking on the colored square next to each trace and selecting a color from the palette. That concludes this basic model building tutorial. For more information on OpenCell, please read the other tutorials on the website.